Hello everyone, my name is Dr. S. Pavan Kumar Reddy, Department of Artificial Intelligence and Data Science, B.V. Raju, Institute of Technology, Narsapur Campus. I deal the subject Introduction to Machine Learning. In that subject, today we will discuss about the types of the algorithms. While coming to the types of the algorithms, here see this entire diagram, all algorithms are available under the machine learning concepts. Here, the machine learning can be classified into three types. First one is supervised, second one is unsupervised, third one is reinforcement. Here, the machine learning algorithm can be categorized the data based on the data. The data is a continuous data, categorical data. Coming to the supervised learning algorithms. These supervised learning algorithms are regression analysis, decision tree, random forest, classification techniques. While coming to the regression, linear regression, polynomial regression. While coming to the classification techniques, k nearest neighbor classification, decision trees, logistic regression, Naive Bayes algorithms, SVM models. While coming to the unsupervised learning, can carry clustering, association analysis, and hidden Markov models. What are the clustering types? SVD, PCA, K-means clustering. In the clustering, not only this, there is a number of types of the clustering algorithms are there, and association rules. What are the association application? Best association applications are a priori algorithm and FE growth algorithm. The last one is a reinforcement algorithm. Not only these three, we are defining one more algorithm is there, that is called as a semi-supervised algorithm. See one by one in the next two upcoming slides. Okay, first one is the supervised, second one is the unsupervised, third one is the semi-supervised, fourth one is the reinforcement learning. These are the four types of the algorithms under the machine learning concept. See one by one. Simply, what is the meaning of supervised learning algorithm? Supervised learning algorithm is used to train the algorithms by using the labeled input and output data. Okay, to train the algorithms by using the labeled input and output data. The performance is accessible by the comparing the trained model predictions and real world output. To train the model or to train the algorithms using labeled data as well as output data, labeled data as well as output data, that is the supervised learning. What is the unsupervised learning? Here can we provide the algorithm with no labeled data. The algorithm can be attempt discovering the hidden patterns. These are the hidden patterns with the training data. Unsupervised learning algorithms can be complex data from the human find the difficult interrupt. Here, this yellow color is there, red color is there, blue color is there. These are the unlabeled data. This unlabeled data will be classified to train the model. After training the model, can segregate the separate data. This is the blue color. This one is the red color. This one is yellow. This is called as a hidden patterns. Hidden patterns are hidden structure. That is the unsupervised algorithm. What is the semi-supervised learning? Here, to learning the model from the unlabeled and labeled data. Labeled and unlabeled data means semi-supervised algorithm is either supervised and unsupervised. To train the model and predict the data After predicting the data will be unlabeled data. Finally, you get the unlabeled data. Simply see this diagram. Labeled data, unlabeled data. These both data are to train the model and predict the unlabeled data. See this example. This is the unlabeled, this is the labeled data. Labeled data means we are giving the quantity, amount as well as label. That is called as a supervised. Unsupervised means unlabeled data. We are not giving the any output. So this type of algorithm is called as a semi-supervised learning algorithm. Semi-supervised learning algorithms. Coming to the reinforcement learning. The reinforcement learning can be allows machine to take an actions to maximize the cumulative rewards. Maximize the cumulative rewards. Reinforcement learning can be learned from the trial and error. Trial and error through reward and penalty. Through reward and penalty. In this reinforcement learning, there is a two important elements are there. First element is environment. Second one is learning agent. Learning agent. In this diagram, what are the two important elements in this diagram? First one is environment. Second one is agent. Okay. The environment agent rewards the agent for the correct actions. To perform the correct actions in that environment agent can get the reward. Can get the reward. If the based on the reward or penalty, the agent will be improve the environment knowledge to make the better decisions. Better decision. See this example. For suppose the agent is in this environment, agent is a small kid. Small kid. The kid having the below 3 years, below 2 years, below 2 years. In that environment, the agent will be perform the correct action. Correct actions mean the 2 years kid having taking the milk, cool milk. Okay, not hot milk. Okay, the kid can be perform the correct actions. At the time only you can get the reward points. That reward points is called as get the 10 reward points. Cannot perform the correct actions, can lose the point, that is called as a penalty. In this reinforcement learning, there is a two important elements are there. What are the two important elements? First one is environment. Second one is the agent. The agent will be perform the correct actions, can get the reward points. The agent will be not perform the correct actions, can lose the points, that is called as a penalty. That is the reinforcement learning. While coming to the classification definition, one more important thing is classification. Here the classification algorithm is one of the supervised learning technique that is used to identify the category of new observations on the basis data. New observations on the training data. In the classification, the model can be make the data set or observation to learn how to categorize the new observation into various classes or groups. Here, the classifier is an algorithm that is used to map the input data to the specific category. Here, in this data, here the x-axis is there, y-axis is there. Okay. Here, in the class A, we are perform the circles. Class B having the triangle circle. Can classify the data either some based on the features that can be classified. These are the A class, this is the B class. Here yes or no, or 0 or 1, or spam or not spam, whether cat or dog, that can be classify the data. These classes can be called as a targets or labels or categories. Targets or labels or categories. This is the classification. Now coming to the what are the types of classification techniques? Here there is a 3 types of classification techniques are there. What are the 3 types of classifications problems is? First one is the binary classification. What is the binary classification? Here there is a 2 class labels only there. 2 class labels. The 2 class labels is either yes or no, or either 0 or 1, or spam or not spam. 2 class labels are there. Only we have discussed about the only 2 class labels. That is the binary classification. The best example of binary classification is logistic regression, SVM models, and decision tree. Okay. While coming to the multi-class classification, the multi-class classification contain the more than 2 classes. More than 2 classes. The best example of the classification technique, multi-class classification is digit recognition, species recognition. Okay. See this diagram. The dog is there. We are assigning the 3 labels. More than 1 class label is there. More than 2 classes. More than 2 classes. Whether the image is dog, whether the image is cat, whether the image is horse. Only more than 2 classes. That is the called as multi-class classification. While coming to the multi-label classification. Multi-label classification. Here each sample is assigned to the set of labels. Each sample is assigned the set of labels or targets. Here the multi-label versions can be a specialized versions, that is conventional classification algorithm. What are the algorithms are available under the multi-label classification? That is the multi-label gradient boosting, multi-label random forest algorithm, and multi-label decision tree. See this example. In this image, the cat is there. This is the cat. This is the bird. How to analyze the multi-label classification? Here in this image, multi-label. This is the one label. This is the another label. What we are predict the labels, whether the in that image cat is available and bird is available. That is the multi-label classification. Now coming to the how to evaluating the classification model. Here once the model is completed, next process is evaluation. The evaluation is its performance. Either it is a classification or regression model. Okay. So to evaluate this classification model based on these different ways. The first one is log loss or cross entropy loss. The second one is confusion matrix. See the one by one. The first one is the evaluating performance of the classifier. The output is probability value between the 0 to 1. The entropy loss value is always between the 0 to 1 only. 0 to 1 only. For a good binary classification model, the log loss should be near to 0. Next, coming to the second evaluation parameter is confusion matrix. The confusion matrix can be provide the matrix table. Matrix table like output and describe the performance of the model. That is also called as a error matrix. That is also called as a error matrix. Here the matrix can be consist of the different predictions. The predictions can be summarized form. Here the total number of correct predictions and incorrect predictions. Correct predictions and incorrect predictions under the summarization form. What is the confusion matrix? See this diagram. The classification model, the confusion matrix is like that. the predicted values, the actual values. Predicted values, actual values. Here there is a 4 parameters are there. First positive, negative, positive, negative. Positive, true, positive, positive, that is called as a true positive. Positive, negative, that is called as a false positive. Negative, positive, that is called as a false positive. Negative, negative, that is called as a true negative. This is the confusion matrix. How to find out the accuracy? Main important thing in the machine learning algorithm to get the accuracy. How to get the accuracy based on this formula only. True positive, true negative by total population. This is the entire total population. Based on this formula, can find out the accuracy of the particular model. The next evaluating model is AUC ROC curve. The ROC curve stands for the receiver operating characteristics curve. Receiver operating characteristics curve, and AUC stands for area under the curve. Area under the curve. It is one of the graph. The graph can be shows the performance of the classification model at the different thresholds. To visualize the performance of the multi-class classification model, we are using the AUC ROC curve. The ROC curve is plotted with the true positive rate, false positive rate. Okay, the ROC curve can be plotted with the TPR and FPR. TPR is called as a true positive rate. YPR is called as a FPR is called as a false positive rate that can be providing with the y-axis and x-axis. Simply see this. This is the x, this is the y. In this x-axis, can define the FPR. In the y-axis, we can be define the TPR. That is the classification. Finally, the next concept is what are the components in the machine learning. The components can be classified into 3 ways. First one is the model structure. Second one is the matrix. Third one is the splitting the parameter. What are the model structures are? Descent race, ensemble models, and instance based methods, neural networks, support vector machines, and graphical models. These are under the model structures. Matrix functions are accuracy, precision, recall, square error, likelihood. These are all are discussed in the previous slides. The next one is the splitting the parameter optimization. We are using the optimization techniques are under the next component in the machine learning algorithm. What are the optimization technique? Combination optimization technique, that are the greedy search. The convex optimization, that is called as a gradient descent optimization technique. The next one is constraint optimization, that is the linear programming. These are the different components of machine learning. What are the challenges? Next, coming to the what are the challenges in the machine learning. There is a different challenges are there. Poor quality on the data, underfitting of the training data, overfitting of the training data. Machine learning, whether the machine learning is a complex process, we are using the lack of training day, slow implementation. These are the different challenges in the machine learning. So up to now, this is the introduction about the machine learning. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.